Hello, and thank you very much for hearing my presentation today. My name is Andy Reid. I lead the International Product Marketing Organisation here at Epicor Software. First of all, I want to thank you for taking the time to join us today. It's always an honour to get to meet with our customers and those of you that may be interested in how we're helping those customers today. So over the course of the next 15 minutes or so, I want to do a couple of things. First of all, we're going to level set on a couple of terms, what we really mean by Industry 4.0, how it's different and how it's progressing. And next, we're going to look at what the core elements are that make up Industry 4.0 and how they're being leveraged in manufacturing. Finally, we'll talk a little about Industry 5.0 that we're starting to hear so much about. So, here at Epicor, our mission is to provide innovative and highly focused industry productivity solutions for mid-market enterprises in the manufacturing and distribution industries. We want to go beyond conventional enterprise resource management systems that you may know as ERP, so that each of our solutions is really comprised of carefully curated software applications and tools that gather, store, manage and share information across your business. So when I say mid-market, our customers tend to be those who've outgrown basic entry-level systems, but maybe don't want the complexity of those huge ERP deployments from the likes of SAP or Oracle. Some quick numbers about us. I'll pick on a few of these. We've been in business for around 50 years. Our customers are in 150 countries across the world. We have over 27,000 customers served by nearly 4,000 employees. And we're seeing many of our customers actually now starting to operate in the cloud. In fact, we've seen a huge pivot towards the cloud in recent years, with 60% growth in recent years and a swing towards those cloud solutions. Okay, so let's look at Industry 4.0 in particular. What I want to do is just step back and call out the links to population and economic growth and think about what that's meant to manufacturing over recent years. When we say Industry 4.0, you might be referring to a fourth industrial revolution. However, some people will argue that we never really stopped the first industrial revolution in the 19th century. We're just seeing waves within that. So let's look at the first industrial revolution, how it started and what the world looked like in terms of population and how things have changed today. You see, the first industrial revolution happened between the late 1700s and the early 1800s. I've shown the period here as a green stripe in the middle of the chart. And during this period of time, manufacturing evolved from focusing on manual labour performed by people, aided by the work of animals, to perform more sort of optimised form of labour with water and powered by engines and other types of machine tools. But prior to this moment in time, the world actually looked quite different. What you're seeing here is our estimates of GDP, of gross domestic product, of the world split into the major economies of the time, and each horizontal stripe represents one of the major economies of the world. So what you can see is up until the beginning of the first industrial revolution, the world's economy was pretty much dominated by China and India. And then after that period of change, the Western economies, particularly that of the United States, began to grow quite quickly and then surged right up until the 1980s. Since then, of course, we've seen the re-emergence of China and other Asian economies. And this chart runs to 2017, but that trend's continued and even accelerated, particularly across the South Asian economies. Let's look at what the world looked like in population numbers. You see, in 1800, world population was only around 1 billion people. So if you think about that for a moment, 1/8 of the global population today. It took about 100 years for this to increase by more than 50% to 1.6 billion in 1900. And then there was that big change in 1928 when Alexander Fleming, in a hospital in the UK, discovered penicillin, which ultimately led to the introduction of antibiotics. It was around this time that the world entered a second industrial revolution with the introduction of steel and the use of electricity in factories. And this introduction of electricity enabled manufacturers to increase efficiency and help make machinery more mobile as well. And it was during this phase that mass production concepts like the assembly line were introduced as a way to boost productivity. And you might consider this to be the technology revolution. Now, until this point, you can see the population numbers really start to surge here, which of course increased consumption, and totally changed the shape of many global economies. So starting in the late 1950s, the third industrial revolution began to emerge. Manufacturers began incorporating electronics and eventually computer technology into their factories. And we refer to this as the digital revolution. So the emphasis became much more on technology, digital technology, and automation software to help production capacity and efficiency. Now, by now, the global population has risen to about 2.5 billion people. So consider that. So in just 150 years, the global population became 2.5 times larger in just 150 years. That's nothing compared to the rate of growth that we saw in the last 75 years. So now in 2021, our population is just over 7.8 billion people, and of course increasing now through 2022, more than 3 times the number we had in 1950. It's no wonder that we need more technology to help us keep up with the needs of world consumption. And this is where the fourth industrial revolution, this fourth wave, is making such a difference, a wave focused around the idea of automation. So in this chart, you can see that rapid growth. And if you look at the dark green shading, and the growth isn't going to ease up until really the light green shading, when we get to around 2100. Okay, you can see the rate of decline has dropped off, but by 2100, we're expecting world population to be around 10.9 billion. Okay. Why am I telling you all of this? Well, as I said, it's because we need to keep up with the demands, and we can't do that with traditional means. We have to use technology, and we have to use it in increasingly advanced ways to keep up. And that's why Industry 4.0 and leveraging all of those elements is so important. So Industry 4.0 is taking the emphasis, it takes the emphasis of digital technology from recent decades to a whole new level, with interconnectivity through the Internet of Things, through access to real-time data, and the introduction of cyber physical systems. Industry 4.0 offers us a more comprehensive, interlinked, holistic approach to manufacturing. It's about connecting the physical with the digital. It's allowing for better collaboration and access across departments with partners and vendors and products and people. So Industry 4.0 is empowering business owners to better control and understand every single aspect of their operation, and allowing them to instantly leverage data to boost productivity and improve processes and ultimately drive growth. Okay. So if Industry 4.0 is about meeting the needs of today's world, before we rush ahead and grab shiny new robots, and other technologies, let's just consider about optimizing what we have today. You see, each of you will have a hidden factory, a hidden factory of untapped capacity within your manufacturing plant. That's the maximum amount of additional production that could be unlocked with without capital investment. Fully utilizing your hidden factory means around-the-clock perfect production, manufacturing only good pieces as fast as possible with no downtime every hour of the day. This term was popularized in the 70s. And specifically looking at the costs of bad work within an operation. So the hidden factory isn't a physical factory, so there's no secret door that you can open to find it. So you can stop looking for one if you started thinking about that. The hidden factory represents that untapped capacity within your manufacturing plant, the maximum amount of additional production, as I mentioned. The things that are contributing to your hidden factory are all the elements that lead to a reduction in productivity. For example, cycle inefficiencies that you may not be aware of, unplanned downtime if one of the machines goes down, scrap and rework potentially caused by human error, and of course quality issues. And with all of this inefficiency, your profits get hit, parts cost more to produce, the value that you can deliver decreases, and so does their satisfaction level. Because of that lack of knowledge in your hidden factory, you're left in a reactive mode, not one that's proactive. Now, in the last few years, when we think about Industry 4.0, there's been a real surge in technology worldwide. And there's lots of initiatives all over in different countries. One of the early initiatives was by the German government called Industry 4.0, but we've seen similar concepts around the world. So Sweden with Production 2030, China with Made in China 2025. And recently I spoke to an audience in Indonesia about making Indonesia 4.0. And we've probably also heard of terms like digital transformation and smart factories. But the common theme is that these are all about using technology to gain a competitive advantage. Now, what's really interesting about Industry 4.0 is that we've been exceptionally lucky with the convergence of three core components that make that up. And the first is processing power. The rapid development of the silicon chip over the last few decades has facilitated these incredible advances in computing power. However, we're nearing the end of this era as silicon begins to approach its limits. Fortunately, the discovery of new semiconductor technologies like graphene is going to ensure that this increase continues. Of course, there's the cloud. To make use of all that increased processing power, the emergence of the cloud is making it possible for businesses all over the world to quickly access this enormous power and scale quickly to meet the needs of their business. Cloud provides a foundation for connected IoT and also real-time communication between machines as a centralized source of insight. And of course, battery advancement. We wouldn't be able to capture all of this data for tools and machines in remote situations without the advancements in battery technology. But the one that's really made the difference is cloud. And we're really seeing an uptake there, as I mentioned earlier on. You see, Epicor recently did a survey and published the results in our industry insights report, where we surveyed over 1,250 leaders across industry. We looked at core questions like, what do you consider, or how quickly do you see the current plans to migrate any of your business systems to cloud-based solutions in the next year? And overwhelmingly, we found that businesses were indeed planning to migrate cloud solutions in the next 12 months, if they'd not already done so. In fact, 99% had at least some plans to do that. Next we asked how interested they were in having these solutions cloud-based, and 94% were very interested or somewhat interested. And this story is consistent across manufacturing and distribution and retail and automotive as well. And why is this? Well, as we all know about the pain of the last 18 to 24 months, we believe this has led to the recognition that cloud provides the most flexible IT structure when things change, when there's huge unexpected change. We've seen many of our customers be able to react quickly when the pandemic hit to keep their employees safe and their customers available to keep buying the goods that they need. Another question we asked was, how flexible do you think your existing IT solution, do you think a cloud IT solution would be to quickly meet your business needs? And 87% of respondents agreed that cloud provided a very or somewhat flexible approach to IT infrastructure. For those that were already on cloud, that rose to 93%. But even from the group still using on-premises solutions, that was 83%. So moving on then, you can see that Industry 4.0 is firstly necessary, but also entirely possible with the technology foundations that we have available today. And if those are the foundational technology enhancements, what are the components of Industry 4.0 that you could be leveraging to ensure that you are at the forefront of the latest industrial revolution? So what we'll do now, we'll review some of the different components. I'd like to just take you through each of them in turn. So IIoT, that stands for the Industrial Internet of Things, a concept that refers to the connections between people, data and machines as they relate to manufacturing. There's huge value in being able to monitor precisely and in real time what's going on the shop floor. By adding sensors and automation to your processes, you've got the chance to streamline operations. This is happening in our personal lives as well, of course. I mean, my daughter is 5 years old, she can't reach the light switches in our house, but she can confidently walk into a room and say to our personal assistant, Alexa, turn on the lights. So these sensors are becoming pervasive in our lives. Big data is a term that's always made me smile. How do you define data that is big? Surely there's just data, right? But this phrase was coined by the major IT consultancies that will tell you that big data refers to these large unstructured data sets or structured data sets that can be compiled, stored and organized and analyzed to reveal patterns. And there may be lots of data in your production facilities that you're capturing today. Gartner refers to dark data, data that is there being captured, but you're not actually managing to make use of it today within your systems. Artificial intelligence is another one. This concept refers to a computer's ability to perform tasks and make decisions that would historically require some level of human intelligence. But it's a tricky area because it's a term that means different things to different people. So, for example, with Epicor Kinetic, we have a virtual agent. We call her Eva for sure, the Epicor virtual agent. You can use natural language to request quote creation or part lookup, which the system will then do for you. However, in other cases, AI is used to refer to machine learning. Machine learning refers to that ability computers have to learn and improve on their own through artificial intelligence without being explicitly programmed to do so. Huge amounts of data is used to create models that can be compiled to suggest improvements, such as forecasting. But in reality, though, these use cases for machine learning will be limited by the amount of data available. There are digital twins, similar to augmented reality. A digital twin is a virtual copy of a physical object. Sensors from that physical object can feed information to the digital twin, and this enables the virtual monitoring of physical equipment. A factory floor worker might be able to watch a machine by following its digital twin on a mobile device. And of course, in doing so, the floor worker does not need to be tied to the machine location. MDM stands for machine-to-machine communication. There's many examples of this. It could be autonomous vehicles moving around the plant, for example, or automated picking bins in the warehouse. Digitization refers to the process of collecting and converting different types of information into a digital format. And this is particularly important in the context of COVID-19. Many organizations are now working harder than ever to go paperless. Being able to digitize a delivery document, store and share that information in a central location is now an essential part of keeping workers safe. So this is a very tangible short-term example, but consider what digitization might mean in the future. Smart factories, that is one that invests in and leverages Industry 4.0 technology and solutions. But why? Surely a factory is already operating with all the money that can be made, but it's not that simple, of course, as we talked about with the hidden factory. And there's always opportunities to improve capacity. With cloud computing, that refers to that practice of using interconnected remote servers hosted in the internet to store, manage and process information. And I'm sure all of you here are very aware of cloud, but if you're not there yet or planning to move, have you really considered all of the benefits that cloud has offered? Real-time data processing is another component, referring to the abilities of computer systems and machines that continuously and automatically process and provide real-time or near-time insights. Let's not forget the ecosystem. An ecosystem in terms of manufacturing refers to all the potential connectedness of your entire operation, inventory and planning, financials, customer relationships, supply chain management, manufacturing execution. And when you consider this in terms of Industry 4.0, this time around, we're living in a hyper-connected world. The first industrial revolution was mainly local, bringing scale and efficiency within communities, perhaps to those neighbouring industries or neighbouring communities. The next brought increased transport and trade, and today we're connected to everyone with this little device, in the palm of our hand. We can speak to our business partner on the other side of the world in an instant. Cyber physical systems, also known as cyber manufacturing, refers to an Industry 4.0 enabled manufacturing environment that offers real-time data collection, analysis and transparency across every aspect of the operation. And we've covered this really across many of the other areas, but I wanted you to be aware of the term. And of course, finally, blockchain, a distributed ledger system to increase trust between trading partners and visibility in the supply chain. Blockchain is an interesting one. Blockchain is an interesting one because it's really about creating trusted and efficient workflows. For example, not just cryptocurrencies. It's actually really useful for things like contract planning, where multi-part deliveries may trigger the next stage in the contract. So it's likely to be something we see an awful lot more of in the next few years. So with so much available as Industry 4.0, are we ready? Are we ready for 5.0? And now I may shock some of you a little by arguing personally, at least, no, I don't think we are. You may hear others say otherwise, but for me, at least, I'd say we're not ready because we're still in that very strange early stage with any trend where we're still trying to work out exactly what Industry 5.0 is. Before coming here today, I asked a few people what they understand by the term. And there seemed to be some general disagreement. Sorry, it seemed to be some general agreement, rather, that it's a coming together of people and machines. Surely that's what we've been doing since the 19th century, right? So to make matters worse, if you speak to the official bodies, you get different perspectives. But if you look at, according to the European Commission, Industry 5.0 is not at all to do with the coming together of humans and machines. It's actually about placing the well-being of the worker in the centre of the production process and delivering prosperity, importantly, whilst respecting the production limits of the planet. So it's about resource management. Okay, so it's about thinking about high levels of production whilst respecting the limits of the people and the resources involved in the production process. And just as a quick review, I thought this was a really nice summary, really, of the development of those various industrial revolutions that have been identified since the mid-18th century, beginning with 1.0 and mechanisation, onto mass production, and thanks to the introduction of electricity with 2.0 and 3.0, that brought us the first appearance of computers and digital automation, and to 4.0, using it's really all about exploiting the data across your business for many different technologies. And that's where I think we are, where we are today. We're on that cusp of Industry 5.0. And interestingly, in fact, this slide identified that mass customization was 5.0, and maybe just an example there of what we mean, that we're still trying to work out what that next stage is. Okay, so really that's the end of my time with you today. What I wanted you to see, I wanted you to leave you with some ideas, and the first is to get comfortable with the components of Industry 4.0. Ask yourself if you're making best use of the technology that's here today. Do this before worrying too much about Industry 5.0, as I'm willing to bet that many of you have still got gains to make. Second, if you're not already doing so, do get on board and begin your journey to cloud. If you haven't started, or if you have started rather, accelerate it really. This is where we're all going to be able to meet the needs of the next generation. And third, of course, please do reach out to Epicor and our partner organisations. We're here to help you on that journey if we can. Okay, thank you very much. Please do enjoy the rest of your day, and thank you for taking the time to listen.